ना इस लेक्चर में हम लोग स्टार्ट करते हैं कॉमन कलेक्टर कॉन्फ़िगरेशन। तो देखिएगा कॉमन कलेक्टर कॉन्फ़िगरेशन, ठीक है बेटा, जो कि हमारा लास्ट कॉन्फ़िगरेशन होगा ना। पहले पॉइंट में हम देखते हैं जो सर्किट डायग्राम है और जो डेफिनेशन है, ठीक है। सो इन दिस सर्किट और कॉन्फ़िगरेशन, collector is common between input and output. So input is in between base and collector, and output is taken across collector एंड इमीटर, ठीक है यहाँ तक। नाउ डायग्राम को देखते हैं तब और ज्यादा क्लियर होगा। सो ये रहा हमारा एक एनपीएन ट्रांजिस्टर एन पी एंड एन। नाउ दिस टाइम आई जस्ट टेक अपसाइड एमीटर, डाउन साइड कलेक्टर, and this is your base, ठीक है। then this is the polarities of the collector, emitter and base side. Now this is the direction of current, so this is your IB and this should be IC, so this should be definitely IC, so it is correct now, ठीक है। यहाँ तक डायरेक्शन ऑफ करंट। नाउ दिस इज IB एंड IE शुड बी आउटसाइड, IB इज आउटसाइड, देन डेफिनेटली IC शुड बी इनसाइड, क्लियर है। नाउ अगर हम सिंबल रिप्रेजेंटेशन देखते हैं, देन वी हैव नाउ इमीटर अपसाइड, कलेक्टर डाउन साइड, देन दिस इज योर बेस साइड, ठीक है यहाँ तक बेटा। नाउ अगर हम इनपुट और आउटपुट की बात करते हैं, सो इनपुट इज एट इनपुट जो पैरामीटर है वो कौन से हैं? इनपुट इज IB, द बेस करंट, एंड BBC, दिस इज बेस, दिस इज कलेक्टर, दिस इज बेस, so BBC। एंड आउटपुट साइड इज व्हाट? आउटपुट साइड वी हैव VEC, कॉमा व्हाट इज इट? I, ठीक है यहाँ तक। सो दिस इज ऑल अबाउट फर्स्ट पॉइंट इन दिस कॉन्फ़िगरेशन। The collector is common between input and output. So input is applied between the base and collector, and output is taken across the emitter and collector, Clear? So input parameter are BBC, IB, and VEC, I. Now the next point is characteristic. सबसे पहले कैरेक्टरिस्टिक में हम लोग देखते हैं इनपुट कैरेक्टरिस्टिक क्या होगी। इनपुट कैरेक्टरिस्टिक, नाउ इनपुट कैरेक्टरिस्टिक क्या है? इट इज अ कर्व ड्रॉन बिटवीन द इनपुट वोल्टेज एंड करंट फॉर डिफरेंट वैल्यू ऑफ, और फॉर कांस्टेंट वैल्यू ऑफ आउटपुट वोल्टेज। सो VBC वर्सेस IB फॉर कांस्टेंट VEC। Now if you have a property of this IB BBC, then this curve is just similar to what? This curve is just similar to your diode forward bias characteristic, because this diode is in forward bias condition. Now as we know that VBC is equals to VEC minus BBE, then this is constant, then VEC increases, BBC increases, then effective base width decreases, recombination in the base region decreases, so base current decreases, clear? And that means the IE increases or IC increases, clear है? So suppose this is the voltage at VCE or VEC is equals to 0 volt. Then as VEC increases, the base current decreases, so base current decreases, so it is VEC increasing now. Now from that the slope is 1 by Ri, that is equals to what? IB upon VBC. Now if you see that base current is decreasing, so slope is decreasing, then slope is decreasing, RI is increasing. RI is increasing. Clear hai? So this configuration has highest input resistance. क्लियर है? ये यहाँ तक बात समझ में आ गई होगी होपफुली. सो पहला पॉइंट डेफिनेशन और डायग्राम के बारे में क्लियर हो गया होगा. देन द नेक्स्ट पॉइंट इज व्हाट योर कैरेक्टरिस्टिक, और कैरेक्टरिस्टिक में पहला पॉइंट इनपुट कैरेक्टरिस्टिक, और उसमें भी हमने अर्ली इफेक्ट को भी काउंट कर लिया है. ठीक है, अब जो है हम लोग आउटपुट कैरेक्टरिस्टिक को समझते हैं. आउटपुट कैरेक्टरिस्टिक को समझते हैं. आउटपुट कैरेक्टरिस्टिक. So output characteristic क्या? It is a curve drawn between the VEC versus IE for different value of, sorry, for constant value लिखते हैं, for constant value of IB. ठीक है, वैसे तो अगर मैं बात करूँ just its output curve is similar to common emitter characteristic, but there is slight difference. How it is? Now IE is equals to IB plus IC. And IC is alpha times IE plus ICBU. Now this take alpha IE left hand side, so 1 minus alpha IE equals to IB plus ICBU. Then IE is equals to IB 1 upon 1 minus alpha plus 1 upon 1 minus alpha ICBU. Now this 1 upon 1 minus alpha terms is called 1 plus beta IB, 1 plus beta IB ICBU. Then this IE equals to this 1 plus beta is called gamma IB plus gamma times ICBU. Now gamma is the highest current gain. So slope. Now if ICBO is 0, then IE is equals to gamma times IB. Then the current gain is what? Gamma is IE upon IB. Now IB is very less, so gamma is high. IE is also high, so gamma is the highest current gain in common collector. So अगर आपको करंट एम्पलीफायर डिजाइन करना है, then you have to choose common collector configuration. Now if you draw the output characteristic, then it is what? IE, it is what? VEC. Then for IB0, ICB0, for ICB0 the IE is equals to what? IB only. Then IB is 0. For IB0, then IE is only equals to the ICBU. Then the curve is like that, but it is high because its value is gamma times. Then you add up this thing, then this curve is like that, more slopey as compared to the common emitter characteristic curve and common base curve. ठीक है, so this is for IB0. Then it is for IB1, IB2 and IB3. Now this region is called cutoff region. Then next is called active region, and this region is called saturation region. Clear? Now the region where the very small current exists is called the cutoff region. This region, and the region where IE is proportional to IB. As you increase IB, IE increases, so IE is independent of VEC. Now the region where small voltage exists is called the saturation region. Now the slope is 1 upon R of naught, that is equals to IE upon VEC. Clear है यहाँ तक? So this having high slope, then the conductance is high, then R naught is lowest. So lowest output resistance. Now if you see the slope of common collector is greater than the common emitter greater than common base. So its resistance, output resistance is lowest, and its output resistance is lowest, but its output resistance is highest. ठीक है, यहाँ तक क्लियर हुआ? Now next thing is what? The gain. Next point is, third point is called gain. So we have also already defined the gain. Gamma is IE upon IB. Now IE is IB plus IC upon IB, then it is 1 plus IC upon IB, then the gamma is 1 plus beta. Now beta is 1 plus alpha 1 minus alpha, then 1 minus alpha plus alpha 1 minus alpha, then it is cancel out. So gamma is equals to 1 plus beta, that is equals to 1 upon 1 minus alpha. So this is the relation between the alpha, beta and gamma. Clear है यहाँ तक? Now next thing is what? Application. If you see fourth point, application. Now application is what? It is having highest current gain. So it is used as current amplifier. The first application. Then the second application is impedance matching. Then the common collector is also known as emitter, follower and the buffer. Clear है? So impedance matching की अगर बात करें, so to drive low impedance load from a high impedance source, that is called impedance matching, and it provide highest current gain. That's why it work as a current amplifier. In some books it is also called the emitter, follower, buffer and different names. ठीक है? अगर मैं इसको समराइज करूं, कॉमन कलेक्टर की अगर मैं प्रॉपर्टीज को समराइज करूं तो क्या निकल के आ रहा है? अगर हम बात करें, its input resistance is infinite and output resistance is 0. अगर मैं प्रॉपर्टीज की बात करता हूं, इसकी प्रॉपर्टीज की अगर मैं बात करता हूं, then the phase shift is 0. Phase shift is 0 between the input and output. Then it is work as an inverting amplifier. Clear है यहाँ तक? And highest current gain amplifier and work as a impedance matching device. Clear है? So this is all about what the common collector configuration. Hopefully ये बात समझ में आ गई होगी. Now इसके बाद जो हमारे numerical part है, common base, common emitter और common collector का, वो start करते हैं.